So let's go ahead and start with problem 3. And the reason I'm starting with problem 3 is because problem 3 kind of takes us back to our first lesson, where the first things we learned were what the basic sine and cosine looked like, and then 3 different transformations we could do: baseline or vertical shifting, amplitude, vertical stretching, and flipping, reflecting, direction changing. All 3 of those transformations are in problem 3. So that's an excellent problem for us to check right now and see, do you understand those 3 transformations? And more importantly, can you do them to a cosine graph? Cosine graphs, typically for students, a little bit more difficult than a sine graph. Okay. So, first of all, I know that the period on this problem is just regular 2 pi, nothing changing, because if I think about the sort of generic setup, the thing that changes periods is having a number b in front of the either just the x or a set of parentheses within the x. So period change impacted by the b. In this problem, my b value is 1, so my period's just 2 pi, so no stretching, no compressing horizontally, don't have to mess with the scale at all. I can just do a normal cosine. So 3 things are going to happen to this cosine. First of all, we're going to go with a baseline that's going to go up 3. We're going to be 2 units above and below baseline for our peaks and valleys, because we know those are kind of the signature parts of the sine and cosine graph. And the negative in front for a cosine, negative cosine, means we're going to start under the baseline and then go up. Normal cosines start above the baseline and go down. So if I draw my baseline in, baseline, 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 baseline. When I baseline a cosine curve, baseline points are at, I think about sort of a 5-point graph. My baseline points are points 2 and 4 on a cosine graph. My first point is going to start under the baseline, 2 units under. Why did I start at the bottom? I'm starting at the bottom because it's a negative cosine. So I'm basically flipping it right now. I'm not drawing it first and then flipping it. I'm showing the result of the reflection. A normal cosine problem would look like that, with the baseline, a normal cosine that moved down starts above the baseline and then comes down to it. So if I put a negative in front, I reverse that, I start underneath it and come up. Okay. So the new baseline's -3? So my new, oh, thank you. That's why you're looking at me so crazy. Okay, I'm like, what? Oh my God, she doesn't understand. Oh, yeah. No. Crap, now I have that on video too. Rewind, erase. No, the new baseline's at +3. Thank you. See, you guys all say thank you to Pizzaria and Chloe for, the rest of you are just sitting there like, she's stupid. Thank you for telling me. Okay. I was so excited about starting under the baseline that I got too excited. Okay. So humbling. Plus 3, how about up there? 2 underneath it, so let's see. Baseline points, baseline points. Is this better? Better? Yeah. Okay, thank you. Once again, I can pretend that I did that on purpose. Yeah, but I didn't. I just did it wrong. Okay. So that's what -2, wait.
You still start at 1?
I'm gonna, well, interestingly enough, since the baseline is at 3, and I'm gonna start 2 units below the baseline, that happens to start at 1 this time. So yeah, it's just coincidence that this still, the first point on this curve is still at 0, 1. If the baseline had been in a different place or we'd had a different amplitude change, that may not have been the case. Okay, so basically up 3 and then plus or minus 2 for the amplitude means my range is going to go from 1 to 5. At baseline 3, positive 3, not negative 3. Who would put that at negative 3? Up to 2 above, 2 below. So 2 above 3 would be up at 5, and 2 below 3 down at 1, flipped over. So here's how I'm going to make you feel. Oh, I'm not going to say it, but let me say that. So let's say you're me, and you're like super excited, and you know what you're doing, and you do something stupid. That's just a dumb mistake, because you know plus 3 means up 3, and you just do it down at negative 3. Let's say you do everything right, but you do it around a negative 3. You're not going to lose all the points, because I can look at your graph. If you had done what I was just about to do before they stopped me, I could see you understand how to do a new amplitude, and you understand how to do a direction change, but you just did it around the wrong baseline. And you're doing a cosine shape. So when I look at a problem like number 3, I can look at, like, that's worth 4 points, sort of 4 different things. Is it a cosine shaped graph? Meaning, you know, if it's got the basic characteristics where the baseline points are and such. And then did you put the baseline in the right place? Did you adjust the amplitude correctly? Did you change the direction correctly? If you had been me down here around this and then doing all that, you would have just gotten -1. And I would have circled plus 3 and probably put a sad face. Just like I feel right now with my sad face, because I was doing it around a -3. Okay. All right. Those are the basics. Those are the things we learned kind of day 1 with sine, and then we threw cosine in at the end, and then day 2 we did more of that with cosine. Anything else on number 3? Okay. New stuff. Let's go up here. Period change. Problem number 1 has a b value of 2, which means the period of my graph is 2 pi over that b value, which is pi. So if we're making some extra notes here, period for sine and cosine is always 2 pi over b. Because I could just ask you on your quiz, actually I probably will, I'll be like, hey, here's this equation, what's the period? You don't have to graph it, just tell me what the period is. And so 2 pi divided by b is what you would be doing, and telling me, you know, how much pi is my period. Also, if you're going to tell me what this graph looks like from 0 to 2 pi, there'd be 2 full cycles. A shorter period, a big B, means a shorter period means more cycles in the 0 to 2 pi. If 0 to 2 pi is kind of our gauge, how wiggly is this thing? So what does it look like between 0 to 2 pi? This guy is wigglier. It's twice as wiggly as a normal sine because it does 2 cycles when we usually just do 1 in that space. So 2 pi, pi. This is usually how I do a pi period. I will just smush my graph. So it will go between 0 and pi, starting here and ending here, just to kind of mark that, my starting point and my ending point. And then I've got to fit the other points in between, which means that guy goes there, that middle point. And then I get my peaks and valleys for sine are going to be 3 off the baseline. So 1, 2, 3, peak, 1, 2, 3, valley, schmuss it in there. And if you want to draw a second one, to kind of emphasize that, you can. Domain, and in this case, range is -3 to 3. Okay, so if you look through the other questions on that particular problem. You can just draw 1 cycle for me. That's fine. Yeah, drawing 1 cycle. And if you draw the cycle kind of squished, that's fine. Or if you want to do, and we kind of talked about this last time, to sort of not cheat. Cheat is not a good word. But, you know, if you do that and go, okay, I'm going to pretend this is just pi, because we figured out that my period is going to be 2 pi over 2 or pi. So if you say, okay, I'm going to scale out 4 marks, which is going to end at pi, labeling that as pi and building me a sign in that space is fine, but I want you to tell me you would actually have 2 cycles. If you don't show me 2 cycles, I think that's probably a good rule. If you can't show me all the cycles, you should tell me how many there would be. How many cycles are there from 0 to 2 pi? There's 2 of them. I'm only showing you 1 from 0 to pi, nice and squished. Not nice and squished, kind of blown up.
What if I write all the dashes up until 2 pi, like you did on the last one?
If you show me all the dashes up to 2 pi, but you show it, the graph stops here, that's fine. Yeah. Because that kind of, even with that space there, that kind of implies that you understand, hey, this is a graph that would normally end here, and I'm ending it here. So that space is kind of indicating that. I know, I haven't quite figured out exactly everything I want, so giving you lots of options. Okay. Other questions about the period change problem on number 1? All right, if you look through the worksheet, let's just take a minute and sort of scan through it. Number 4 has a period change. Number 5 has a period change. On the back, 7, 8, 9 all have period changes. And 12, even though we didn't do 12, we talked about specifically skipping that for now. 12 had a period change. Okay. The hardest one for me to do, and the one that I thought would be weird period change wise, was number 7. So let's go ahead and do number 7. Okay. 7, I definitely not cheated, but I definitely said, yeah, I think I'm going to just do a modified scale. Because on number 7, when I take 2 pi over b, or 2 pi over a third, which means 2 pi divided by a third, which keep, change, flip, means 6 pi is your period. Now, I started, and you can see, I started to draw it, and then I did a whole big bunch of whiteout, because I was like, I can't make that work. I was going to try to scale it all the way out to 6 pi, and then I realized, well, that's a lot, because I'd have to do to 2 pi, and then to 4 pi, and it just was taking forever. So what I did, I cheated a little bit, and I went, ooh, 6 pi, miracle. Okay. Which would mean that would be 3 pi, halfway. And graphed a sign fitting in there. But this is a perfect example. I may not ask you to graph something like this, but I would definitely love for you to tell me. From 0 to 2 pi, you have how many cycles in this scenario? From 0 to 2 pi, how many cycles do you have? Because this is like, I don't have, well, let's look at my graph. It takes me all the way to get to 6 pi to do 1 cycle. So how many cycles is almost a trick question the way I'm asking it. A third of one, yes. What part of a cycle? I have a third of a cycle. Now that's really hard to show, because that would mean like you have this much, that would be like a third-ish, and then this would be kind of the second third, and then this might be like the third. So dividing it in halves is really easy to do. Dividing it into thirds is kind of weird. So I know that that's going to be a weird, awkward looking curve to make. So I'm totally fine with you not trying to draw me a third of something from 0 to 2 pi and just kind of going, okay, yep, I'll just do the whole thing out to 6 pi. But the value of b tells you how many cycles, or what portion of a cycle you have in the 0 to 2 pi. So if we could put it on the same scale, right, so this is 0, oh, no, it's not 0. This would be pi, this would be 2 pi. I would have only kind of gone, because my peaks where? My peaks at, my peaks at 1.5, or 3 halves, so 3 pi over 2. So that actually kind of goes like this. That's how much you get. That's a third. That's hard to do. Okay. If that, oh, that's on the wrong graph though. But, so, let me go back to that. Let me undo that on there. But, so once we start getting into the larger periods, like 4 pi, 6 pi, things like that, and sometimes even the super small periods like pi over 4, it's easier to kind of adjust your scale, draw it relative to a new scale, but then give me an additional indication of what I would be expecting. What would I see if I could look at just 0 to 2 pi, what would I see? All right. So the first day when we learned this, we did baseline changes, we did vertical stretches or amplitude changes, we did direction changes. The next day we added on period changes, which we incorporated more last class, and then we talked about phase shifts. Phase shifts are the C value right here. When it's plus C, we go to the left. When it's minus C, we go to the right. So if I was doing problem number 2, I'd be taking this graph to the right, pi over 2. Now, we can do phase shifts of any increment. I'm going to stick with increments that make sense for our scale. So for our particular scale, the way we typically scale these with our 2 pi scale, pi over 2 is a single unit. So here comes my new baseline. Cosine graph starts above the baseline. This doesn't have any amplitude change. So without the phase shift, I'd be looking at this graph. Right. In order to phase shift this, I would need one more increment this way. My baseline points would move over. My top and bottom points. And I would get that. The way I'm going to be able to tell you did a phase shift is you're either what your little section of graph looks like kind of relative to the y-axis. We've either moved to the right and we're starting away from the y-axis, or we've moved to the left and we're starting over here kind of in quadrant 2 and going through the y-axis. All our other graphs, when we're not phase shifting, that first point is sitting on the y-axis, whether it's sitting on the origin or at another point of the y-axis. When I phase shift, this graph moves off of the starting on the y-axis for that first point to kind of either be floating out here in this quadrant or over here in this quadrant. Chloe.
What point is that at? What's the highest point it's at?
The highest point this one is at, yeah, it looks like I've made it higher. The highest point this one's at is at 3. Okay? Because this is at 2. Yeah, I didn't mean to make this look higher. It just how I'm saying. So it looks like this range would be 1 to 3. Because it's a baseline of 2 and an amplitude of 1. So a 2 baseline, 1 upper and below, so 1 to 3. Yes.
Depending on what the pi over 2 is. Basically, is that where you start? Like
That's what I do. That's how I typically do it. I start with where's my baseline? That's what I call it, like the new x-axis. So that plus 2 tells me, okay, that's going to be where I'm going to. The pi over 2. So that tells us how far I move from the starting point. So if I was, unless you were going backwards, if you're going to the right, yes. If you're going left, If this was like x plus pi over 2, then you would move back to negative pi over 2 to start.
So, can you do number 10 then?
Hmm?
Can you do number 10?
Yeah, let's do number 10. I think that sounds like a great plan. Does that got the pi over 4? Oh, I hate number 10. Yes. I hate number 10. And I say that like I'm not the one that wrote the worksheet, but I did write the worksheet in 2015. So like 7 years ago, I must have liked number 10. But now I'm like, ooh, yuck, I don't like that worksheet. I will change number 10 for next year. So let's change number 10. Or let's do number 10. We're not going to change it now. This guy's going to go left. He's going to go left 3 pi over 2. So that means, and what I had to do here on number 10 when you look at my key is I had to redraw my axis because I was like, I don't have room to go left. So backwards left, this would be negative 3 pi over 2. So my sign that usually looks like this, and it has sort of 1, 2, 3, 4, 5. We're going to use these points. We're going to use 1, 2, 3, 4, 5. Okay. Sorry, yeah? No? Yes. Okay. So now, let me do some other stuff to it. Up here at 3, seems to be my favorite baseline. Amplitude at 2, but flipped. And a sign. Okay, so when I draw a sign, signs start on the baseline, and then the third point is on the baseline, and then the fifth point is on the baseline. And then this guy is 2 below, and this is the one that's weird. It always gets weird. You kind of, so it's 1, 2, 3, 4, 5. Yeah. Yeah. So, okay, yeah. When you phase shift, is that just where it starts? Yes. Yes. I had to think about that before I made a commitment to that. But yeah, if you have it written a certain way, all right, that's going to be the caveat we're going to, or the as we do number 12. If we have it written a certain way, then the phase shift will be sort of where it starts. Now you got to be, if it's a minus 3 pi over 2, it's going to start at positive 3 pi over 2. If it's plus 3 by 2, it started over here at negative 3 pi over 2. So you got that like reversing thing down. Okay. All right. Last thing we're going to talk about is number 12. Because number 12 has a period change and a phase shift. It's got this and it's got this. Okay. Now, when I have a problem with period change and phase shift, this is how I want it to look. I want to have my trig function, and with any other stuff that's going on, and then I want my b, and then plus or minus c. Like that, in parentheses, with a b factored out. If I don't start with a problem that way, I'm going to want to make it be that way because that will make things easier. Okay. I am going to let us, I think, hang on before I say this. Yes, I have done that for you on all your problems. So we're not going to worry about making that happen today. for our quiz. We'll worry about that in the future. But this is what we want to be looking at to combine a period change and a phase shift. Okay. So then we can do exactly what we can use, kind of the Bizarria trick, and she's like, oh, phase shift, this is pi over 2 to the right, so I know this graph, the first point is going to start at pi over 2. Okay. However, period is 2 pi over 2, which is pi units. Which means we're going to end at pi plus pi over 2. This is the part that's tricky. Before, when we did a period change, wherever our new period was, that's kind of where we ended one cycle of the graph. When our new period was pi, we ended one cycle at pi. When our new period was 4 pi, we ended one cycle at 4 pi. In this case, because we've got shifting going on, we have to take the period ending spot and add that shift, or if we were moving left, subtract that shift from it. Okay. This is one of the hardest combinations. You're fine, come on in. Okay. Thanks. Okay, so here we go. Pi over 2 is where this sine curve is going to end. Pi plus pi over 2, or 2 pi over 2 plus pi over 2, is 3 pi over 2, which means 3 pi over 2 would be right here, because this is pi, and this is 2 pi. I'm going to do one cycle of sine from here to here.
So you still end at 2 pi?
Still,
Like, so we end at 3 pi over 2, like you end the graph there?
yes. We're going to end the graph at 3 pi over 2. We're not going to worry about talking about, we're only going to do this maybe one time on the quiz, so we're not going to worry about talking too much. We're going to hope we can get it to, if we can get it to start and end at the right labeled places, I'm going to be happy for that. So a sine curve that fits here will go like that. It's a started and ended problem. Now, I don't know, this is when I start giving you like other ways to think about that. If you don't like that, let's try it another way. Okay. Same problem, sine 2 x minus pi over 2. If you worry about the period first, my period's 2 pi over 2, which is pi. So don't worry about that right now. And let's just, do something ugly. Okay. Let's just graph. Boop, 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 boop. So there's 2 pi. There's pi. I'm going to put my sign from 0 to pi. So it's the squished up sign. So there's my squished up sign. And now, if everybody goes right pi over 2, new starting point here, new ending point here, And that started at pi over 2 and that ended at 3 pi over 2. You might like that better because then you don't have to, it's just after you get it set in the period, you scooch it over. Okay, you scooch it over 1 unit. Everything's a little more smushed together. So when you scooch this together over 1 unit and you scooch this over 1 unit, these are just going to feel a little weird. It's still going over 1 unit, but it's just going from like sort of in between here to in between here. You might like that better. I think I like that better. I think that's actually how I do it. So the only thing about that is it kind of gets away from talking about that this represents your starting point. But that's a good trick. I like that you can maybe put it all between 0 and pi and then move it. Okay. The hard thing about teaching this is I can talk and talk and talk and talk and talk and talk. I mean, good grief, I've talked for 36 minutes. And I really have no idea if you guys are where you are on doing it or not doing it. So I've got to stop talking and I've got to let you do it. And it's got to just get messy and let me help you as you need it. So I'm going to give you worksheet 3. If you're working on worksheet 3 is sort of everything mixed together, some easy, some difficult, all different combinations, which is more accurate to what you would see dealing with on your quiz. You can be working on finishing worksheets 1 or 2 or working on worksheet 3, but I would expect you to be working on one of these things. And I am going to be bebopping around in my best bebop mode. See if I can help. Okay? You are absolutely not going to be able to do this on a quiz if you don't practice it. And you are not going to be able to fake it. So let's see if we can't figure it out. Oh, we didn't do that one. Okay. All right. So let me, I'm going to